from the beginning, when I first got into this field, I came in kicking and screaming because I didn't believe in these things. I thought this was due to fuzzy thinking. And then in encountering the literature, I was blown away by what seemed to be so many good experiments showing these effects.
Hello, everybody, and welcome back to Chasing Consciousness. Today, we're going to be talking about the experimenter effect, and this is a very, very important element to the conversation we're starting here in the first series, because it really could turn out to be quite a limitation and quite an extraordinary example of human interaction with the scientific method and the scientific process, taking objectivity to a slightly spurious level. But this is something we're going to find out speaking to a professional scientist, Dr. Garret Moddel. So Dr. Garret Moddel, professor of electrical and quantum engineering at Colorado University, specializing in solar cells, metal-insulator technology and geometric diodes, and optoelectronics, among other extraordinary technologies. However, he also runs a separate lab in a totally different field of research, which we're going to get into later in the interview. And this really helps us to understand why he had such a strong run-in with the experimenter effect, and why he is literally the perfect person to speak to about this. So, without further ado, let's go. Hello, Dr. Moddel. Welcome to Chasing Consciousness, and thank you so much for taking the time out of your busy schedule to join us. How are you?
Very well. Thank you for having me.
Well, it is a great, great pleasure. So tell us a little bit, Dr. Moddel, about your research at the University of Colorado. What's the bulk of your career been investigating, and what are you most proud of? What were the great moments?
So my work has been mostly in looking at new renewable energy technologies based on fundamental quantum principles. And so it started with solar cells, gone through a number of different sorts of devices. Right now, the main work of the laboratory is a device called an optical rectenna. And it turns out that for most solar cells, the way you absorb light is by absorbing photons in a semiconductor medium. The incoming light frees an electron, and in order to collect the power from that, it has to go through an external circuit. We're doing is very different. We're treating light like waves. So the light comes in to a submicron-sized antenna. It's picked up like a radio wave and then channeled to what's called an ultra-high-speed diode. So that's something that changes the alternating, oscillating wave into a DC power. And so we've been pioneering this technology. It's very difficult because the frequency of light is something like 10 to the 14 or 10 to the 15 hertz. So that's humongous. That's thousands of times faster than electronics. And so it's a challenge, and it's also a lot of fun. And at those frequencies, without going into detail, it's actually a quantum mechanical problem rather than a circuits problem. And it makes it very interesting.
Fascinating. Okay, Dr. Moddel, let's get straight to the subject of today's conversation, the experimenter effect. Yeah. Now, in this first series, we're aiming to have take a really close look at the process of gathering data scientifically from the physical world, so the quantum mechanics and the physics side of things, but also from the mind's point of view, from the psychology point of view, and from the neuroscientific point of view. It strikes me that the experimenter effect is really, really important in the scientific method. But I want to really delve into this with you today. First of all, give us a little summary. What exactly is the experimenter effect?
So the experimenter effect is a consequence of an experimenter expectation on their results.
Mm-hmm.
So if you as an experimenter expect to see something come out negative, then you might in one way or another influence the results so that it does come out negative. And the means for that influence, I'm sure you'll be asking about that, but it can be very conventional. So in a psychological experiment, if you expect to have a null result from a particular stimulus, you might inadvertently influence the subjects or the people working with you to try to produce that result. In physics, it's a different and more subtle issue, since we can't really influence physical systems. At least that's the conventional wisdom.
Right. And what are the methods that science usually uses to avoid, at least as much as possible, this potential problem? Because it's quite an old problem, isn't it? It was noticed quite a long time ago.
It is. And it goes, there are stories about Benjamin Franklin doing work to examine the effects of certain phenomena. And he made use of what we would now call a control experiment, in which you run a control, and then which means you run the experiment without the influence to produce the effect that you're looking for, and then you run the experiment with the influence. And when in order to avoid an experimenter effect, you want to run this double blind. So in other words, you should not be in any contact or with the people actually running the experiment or with the subjects, so that you don't inadvertently influence them. Then one can go a step farther, and we've done this in some experiments, and that is go triple blind, where not only does the subject not know what's being tested, but also even the experimenter doesn't. So you do some sort of a randomization beforehand, so you don't even know what a particular outcome would signify.
Right. Extraordinary, and quite a brilliant method. And presumably there's this scientific methods request, which is about reproducibility, the ability to reproduce an experiment. A completely different researcher could come in, do the same experiment, and get exactly the same results. Now, that should get around the problem, shouldn't it? But surely that only gets around the problem if the repeating scientist has a different expectation.
Right. So if you are running an experiment where you've double or triple blinded it, and it is not a statistical result, then presumably you can rerun it and get the identical result. And so that is replication, and that's crucial to believing any sort of phenomenon. There are problems, particularly with a lot of experiments that are being run today, in that we're dealing with statistical phenomena. So if we're doing a psychological experiment, humans don't do the same thing every time. There are many outside influences that are uncontrolled. And so you end up with a statistical distribution of results.
Right.
Therefore, you can't really expect to see exactly the same thing every time. Instead, you need to be able to statistically see the same sort of bias every time.
Mm-hmm.
But that still is considered replication. In other words, if you statistically can see the same result over and over, you have in fact replicated the experiment. Now that we're dealing in physics with quantum phenomena, they too are statistical in the results. So we don't. It's not like dropping a ball, and every time you drop a ball, it's going to fall at the same rate, and you can measure that. If you're dealing with electrons bopping around in a material under the influence of thermal fluctuations and various other things, that's a statistical experiment as well.
Is this the same, sorry, Garrett, is this the same as the difference between a qualitative and a quantitative experiment?
No, it's not. A quantitative experiment is where you are measuring a result with numbers. So if you force something with 2 newtons, you'll get a different result than if you force it with twice that.
Mm.
And so if you see that the response is proportional quantitatively to the stimulus, you've done a quantitative experiment.
Mm.
A qualitative experiment, on the other hand, is where you would say, I know that if I eat, I'll feel stronger. And so
Yes.
you eat and you feel stronger, but you're not measuring how much you ate or how much stronger you're feeling.
Exactly. And so you would have to, that would be subjective based on your understanding of what it was to be strong, which is more of an emotional or a personal point of view.
You raise a good point. So there is the problem with qualitative experiments that subjectivity can come in, and the whole idea of not allowing subjectivity to come in. The purpose is so that we can run an objective experiment and we can measure things. And if we can measure it, then you say, okay, it's not subjective.
Well, I only mention it because I know that a lot of, for example, for pharmaceuticals or the testing of drugs, there's a lot of psychology research which, de facto just needs to have a qualitative element. And so this idea of reproducibility is almost absurd. But could you just mention that again you mentioned about a statistical range. So you're looking at a sort of range of statistical results.
So we've developed, we being the scientific community, have developed very sophisticated statistical tools for analyzing this. So, for example, if you look at the effect of a certain drug on someone, and you find that there are a statistical distribution of results in how well it seems to help people, if you can then apply statistical inference techniques and come up with what's called a p-value. So a p-value, very loosely speaking, is odds against chance that what you've observed is due to the influence as opposed to just randomness.
Exactly.
So if you have, for example, a p-value of 0.05, that means that there's 20-to-1 odds that the effect that you've seen is due to the influence that you intended it to be. There's always 1 in 20 chance that it was just random. And so what you want to do is run the experiment and develop the experiment so you have high statistical power, meaning that the p-value, the odds against chance that your experiment is just random, is very, very small. And you can do this. And the way you do this is by having many trials, by and various other statistical techniques. So we can quite robustly say, even though the result is statistical, we can say, yes, it is due to the influence that we expected, and we can give you the exact odds against chance that that's the case.
So before we move on, Garrett, into your extraordinary story of your very personal run-in with the experimenter effect, which I absolutely love this story and I can't wait. Is there anything else that you think that the listeners need to understand about how important this is in the scientific method and how seriously the scientific community takes this problem?
So the experimenter effect is taken seriously in human sciences, in psychology and the like. It's not taken into account at all in the hard sciences, in physics, chemistry, and so on. And in fact, we may get into this, but it's poo-pooed quite a bit and thought to be due to fuzzy thinking.
And why is that? How did that come out?
Because if we believe in a purely materialistic and
mechanistic
perspective, that's a better word, mechanistic perspective, then the physical parts of the experiment are the only thing that influence the result. And therefore, how could an experimenter influence the result with the experimenter's expectations or intentions? So to think otherwise is fuzzy thinking.
Well, talking of fuzzy thinking, this brings us to your second lab. You run a second lab, don't you, at Colorado University? I'm not sure if it's actually at Colorado University, but you do run a second lab. And I think it might be a good moment to introduce what that lab experiments with and tests for, because it's going to be very important as we come on to explain your run-in with the experimenter effect. Tell us a little bit about what you're researching in your second lab.
So the mainstream lab I run, it's called the Quantum Engineering Lab. The other lab we're calling the Cybotics Lab. And it is a lab in which we take a look at the subtle influences on humans, on physical systems and other humans. And it's research that's non-mainstream. I actually keep the two labs quite separate. Even the websites are totally separate and so on, not to contaminate the reputation of the students of my mainstream lab, simply because at this point the scientific community is fairly skeptical of some of these effects.
They're known as psi effects, aren't they? PSI, psi effects. Could you just give us a very quick rundown on what are the big three psi effects?
So psi is a combination of ESP and psychokinesis. So ESP is precognition, knowing things in advance, clairvoyance, so being able to see things at a distance, telepathy, conveying thoughts directly between beings, and then the fourth one, psychokinesis, is moving things at a distance using your intention.
I think it's so wonderful that such a big proportion of scientists, such as yourselves, professional scientists, feel the need to look into this, especially with the implications it has for mind and the implications of these early experiments in quantum physics of the observer effect. But we're going to come back to that later. The reason I asked you to introduce that now, Garrett, was because this experiment you're going to show us the extraordinary power of the experimenter effect and how convincing that was to you and to your colleagues. Includes this important piece of equipment, the RNG, the random number generator. So just before we talk about your experiment, could you just tell us exactly what is an RNG and why did Helmut Schmitt start using it in these experiments and when? And what kind of effect was he using it to test?
So an RNG is a random number generator, sometimes called a random event generator. And it's essentially an electronic coin flipper. So just as when you flip a coin, it comes up heads or tails randomly, so the output of an electronic random number generator gives you a 0 or a 1, and as to which one it is completely random. What's meant by completely random? So the most random that we know how to make something is quantum mechanically random. In a quantum mechanical system, it may sit in a superposition of different possible outcomes. Then finally, when it does collapse into one outcome or another, that can be totally random. In other words, there should be absolutely no way to influence it with any external mechanism. And so Helmut Schmitt, who at the time was a physicist working at Boeing, I believe, developed a quantum mechanical random number generator in which he used atomic decay, which is a totally random phenomenon where an atom decays from one state to another at a random time. He used that to determine the output of this random number generator, and it ended up giving a bit stream of zeros and ones. This is needed for all sorts of phenomena, for all sorts of technological applications today, most fundamentally for cryptography and other applications like that. And so there's a lot of work in the mainstream on making really good random number generators, even to this day. And so once Helmut Schmitt had his random number generator, then he veered off and started using it for looking at psi phenomena. And he was one of the pioneers in the field. People have been looking at psi for centuries, but only really in the mid-20th century did it become a rigorous science using these statistical methods that I mentioned earlier to be able to determine whether the result you're looking at is due to random chance or due to what you had intended it to be. So Helmut Schmitt did this, and he ran all sorts of experiments. One of many that he wrote about is where he would have somebody wear a headset with two earphones, and he then had a random number generator that produced clicks either on the left side or on the right side randomly. And he then had his subjects use their intention to determine whether they would get more clicks on the left or more clicks on the right. And he found that statistically, they were able to do this a significant number of times.
And it's so difficult for us to understand these kind of figures, but what is a statistically significant result in this case?
So in the psychological literature, a p-value of 0.05 or less is considered statistically significant. That means that the odds against chance that it was due to just a randomness in the experiment are 20 to 1. Okay. And so for these sorts of experiments that Helmut Schmitt and others have done it, the demarcation line is 0.05 in the p-value.
And that's a 20 to 1 chance against this result, basically.
Right. Although many of us, for many experiments, get p-values that are far, far smaller when we do experiments rigorously and with sufficient number of trials.
Well, no, because it strikes me that this might be one of the biggest bones of contention, would be a misunderstanding of the importance of that kind of result. Whether it's, as you say, these variations in p-value, these variations in probability against randomness, I think that could be vastly misunderstood and misinterpreted. But I imagine that Helmut Schmitt wasn't one of the only scientists to go on to look into it. So just before we get into your experiment, can you just tell us a few of the other scientists who, if I understand correctly, there are really quite a few, like yourself, really serious professionals who, on the side, quite quietly, in order to maintain their reputation, were doing this research with quite extraordinary results. Can you give us a couple of examples?
Yes, there's actually quite a number of such scientists. And there are, at this point, literally thousands of peer-reviewed publications on these effects. So this is a data-driven field. It's not fuzzy thinking. You had discussed earlier the difference between quantitative and qualitative experimentation. This is quantitative. Yeah. These are numbers, and there's real data supporting it. So there are a whole host of people doing it. Some of the more well-known people include Dean Radin, who actually worked on this first at Bell Labs, and then has carried out research. He's carried out some brilliant experiments looking at the effect of human intention on all sorts of physical phenomena. Then Bob Jahn, who was at the time Dean of Engineering at Princeton University, was asked by one of his undergraduate students if she could do an experiment on the effect of intention on physical systems. And he sort of half seriously said, sure, why not? And then when she ended up getting positive results, he started taking it seriously. And to make a long story short, he set up the Princeton Engineering Anomalies Research Lab, which ran for 28 years in the basement of the engineering building in Princeton. And the PEAR Lab put out a huge number of experimental results and data showing these sorts of phenomena. And the research continues. There's as you said, quite a few scientists who, for the most part, do this on the side. Some do it as their main work, but generally not.
So, Garrett, that brings us to your extraordinary run-in with the experimenter effect. Can you just tell me a little bit the pretext for your experiment? What was it that you were unsatisfied with in the original experiment? What were you altering to? What were you trying to prove? And then just tell the story of the experiment, because it's a beauty.
So we've run a lot of different experiments, but from the beginning, when I first got into this field, I came in kicking and screaming because I didn't believe in these things. I thought this was due to fuzzy thinking. And then in encountering the literature, I was blown away by what seemed to be so many good experiments showing these effects. And I still thought this must be in the realm of conventional physics, that in some ways that we just have not quite understood yet. And for years, my push was to try to get animate systems out of these experiments. In other words, can you do a psi experiment without these sentient bags of salt water we call human beings? And so finally, after quite a few years of thinking about it, it crystallized one way to do this. And if you permit me a little deviation, I would like to explain it in terms of another experiment that some researchers have done.
Please.
And that is that there have been a number of experiments showing presentience or precognition. That is, the ability of people and others to, meaning animals, to sense in advance something that was going to happen. And there are many different types of experiments. One of them that I like because of its simplicity is one that was set up by two researchers, Spottiswoode and May, by the way, both of whom are physicists. And this experiment involved taking a poor subject and putting a horn next to their ears, an electronic horn. And at a random time, determined by this random number generator that we talked about earlier, at a random time, the horn would go off. All the while, the subjects were hooked up to some pieces of apparatus that measured their autonomic responses and their physical responses. The one that's most sensitive is called a galvanic skin response measurement, which is a measurement of your skin conductivity. And if you are startled or something like that, within a small fraction of a second, your skin conductivity changes. And so you can measure that. And so as you would imagine, when the horn went off, the people's skin conductivity went haywire. But looking carefully at the experiment, they found that this response started a couple of seconds before the horn went off, even though the horn went off at random times. And by doing this dozens or hundreds of times, you could get statistically very strong results showing that there was this pre-response.
What are we talking here? How long?
About 2 seconds.
2 seconds?
In their case, it was about 2 seconds, yes.
Oh, my Lord.
There are other experiments where the timescales are different, but in that case, it was very clear, and the data is clear, and there's really no questions about the data. You might interpret it different ways.
And Garrett, excuse me for the aside. Presumably, this is part of our fight or flight kind of survival wiring. I mean, this is an extraordinarily useful tool.
And you could very well think if a saber-toothed tiger is about to attack, perhaps there's a pre-response there too, and you do get a subtle warning a couple of seconds beforehand to watch out.
Interesting.
So what we did is we set up the same experiment, but without any human beings. So we had one random number generator, which we call the controller, which then at a random time would shut off a second electronic random number generator. And this one we call the subject random number generator. And the subject random number generator spewed out a bit stream of zeros and ones. And it is a true random number generator, meaning that it's a balanced stream of equal numbers of zeros and ones. And this was tested. It's a commercial system. And we recorded this in a computer. Then the idea was to have the controller random number generator shut off at a random time the subject random number generator, and we wanted to see whether the subject random number generator would be able to anticipate its own demise, whether it would be able to know in advance that it was going to be shut off. And I thought this was a perfect way to run the same experiment that Spottiswoode and May ran with the human and the horn, but with electronic instruments, no human intervention whatsoever.
And what was your sort of preconceived notion there? Was this a sort of panpsychist approach that there is consciousness in all things, regardless, of whether they're alive or not? Or was this more of a sort of, this is not a living being phenomena, it's a universal phenomenon? What was your preconceived, what was your expectation?
Exactly the latter. That it's a universal phenomenon. It's not a human consciousness or any sort of consciousness thing. I was coming at this from a very mechanistic point of view. I really didn't want to believe in the woo-woo of consciousness controlling things and so on. I wanted just a hard physics experiment. And that's how we set it up.
And your hope was that the original experiment that showed this precognition of potentially up to 2 seconds before the alarm went off, you wanted to show that this was just a normal part of the physical world. It showed no sense of presentience or precognition. It was just part of hard physics we just yet hadn't understood, a kind of lapse in time of some sort.
Yes. I mean, I did accept that it was a sort of presentience where perhaps put in quotes the word sentience in the sense that a machine could sense this as well.
That in itself has big implications, doesn't it? Anyway, do go on. What were the results? How exciting.
I had one group build the basic apparatus, and then one of my grad students who was actually working on something completely different, but was very good at computer programming, did the software for the system, James Zhu. And so he set this up. It took a long time. He did all sorts of tests to make sure that we knew exactly when the shutoff was occurring, and that there were no outside influences and so on. And I remember the first evening that he went to run it. We were very excited to see the result. And because we didn't need human beings, we could run as many trials as we wanted quite rapidly. And so we ran 300 trials. And in those 300 trials, we got sort of random bits coming out of the subject random number generator until about a second before the shutoff was to occur randomly, at which time it produced more zeros than ones, and a large number, very statistically significant number, more zeros than ones. This was about one more zero per 40 bits than ones, and that's a lot for a statistical effect. And we were tremendously excited. So then he ran it again for roughly another 300 trials, got the same effect. Ran it again for another 300 trials, same effect. We put this together and had about 1,000 trials altogether, in which 1 second before shutoff, the computer, the random number generator, really did anticipate its own demise.
It deviated from pure randomness.
It deviated from pure randomness. We were tremendously excited. The odds against chance for this experiment were infinitesimal. The p-value was something like 1 millionth, 0.5 zeros and a 1. So I went home thinking this had been the coolest experiment we've ever done. Now we can do psi research without human beings. Now we can use it for all sorts of things. We can use it for predictive mechanisms. If you want to predict the stock market, you can do that, and all sorts of things. And so over the course of the next week and a half, we wanted to try to refine it. And so James tried changing things. We changed the bit rate, we changed the number of trials, and then thresholding and various other things. And it didn't work. It really, the initial way that we'd done it seemed to work the best. So then finally, a little less than 2 weeks later, we reran the first experiment entirely. So same equipment, identical software, everything exactly the same. We got a null result. There was no deviation before shutoff.
Was this a different team operating the experiment, or was it was the same team?
Same James, same me. Exactly same thing. And I went home devastated. It just dawned on me that I had tried to be so smart and get the experimenter and the human beings out of the experiment. But in fact, we were running an experiment in which it was our intention that was causing the result. It wasn't just the machine. And
so there's only really two options here, isn't there, Dr. Moddel? On the one hand, it may be that it was just wrong and it was just not a real effect, or it may have been that there was an experimenter effect. But in either case, we're looking at psi effects, aren't we?
We are definitely looking at psi effects. I was pretty convinced it couldn't be wrong. We had date stamps for each bit, time stamps, so we knew exactly when each bit was coming out onto the computer. It was done very carefully, the first experiment, so I believe it was done right. Then, just to be doubly sure, that summer I had another student build his own electronic random number generator and do the same thing, and he got the same result. It worked really well to begin with, and then the effect declined and essentially went away after a while.
Right. So it's either way, we're looking at some sort of mind-matter interaction, some sort of psi effect, aren't we? Well, let's back up a bit, Garrett, because You, I imagine, are one of very many scientists who, like me, I mean, I'm not a scientist, but until really quite recently, I knew nothing about this research. I didn't know it existed. It's not well publicized. It's not in the mainstream media. It's not in the scientific magazines. So I think the general public are really not aware that this is actually taken seriously by scientists. Can you tell the story and also maybe tell us when this happened to get a sense? But tell us the story of how, first of all, this was drawn to your attention, and what was the kind of jaw-dropping moment where you just actually went, "Oh my God, this is real"?
So I think for many people, they start to investigate these phenomena from an experience that they may have had, something very strange happening. I, early on, decades ago, told myself that the mind plays tricks on itself. And if I see any sort of strange phenomenon occurring that looks like it might be psychic, that it's obviously my mind fooling itself and not to believe this. And so the way I got into this was during sabbatical in 1999. I came across a quantum physicist, a theorist, who had on his website parapsychology. And I was very puzzled why somebody with a good reputation would have that on his website. And he then let me into his library. And he had a whole room devoted to books on what some people call parapsychology or psi phenomena. And I was flabbergasted that there was such a literature, and I ended up spending the rest of my sabbatical learning about this. And then when I came back from my sabbatical, I decided I had to get into this and found an organization that was working on this and became very involved in it. That is the Society for Scientific Exploration. And it's been a very exciting ride the whole way.
I mean, apart from the seminal work of Helmut Schmitt, who, like you've said, did this work in such a meticulous and utterly objective way, without any sort of, as you put it, woo-woo influence in his thinking. Apart from Helmut, can you give us an example of somebody with just an impeccable reputation who, just give us an example of one experiment that, in your experience in Alex Gersten's library, where you just, was there a draw drop moment? Was there a moment where you just read an experiment and it was just, you couldn't doubt it any longer?
There were quite a few of those. One person who comes to mind is Jessica Utts. She is a statistician, and I can't remember the name of the American Statistical Organization, but she has been president of it. She's been a professor at the 2 universities in California, is really the sort of person you talk about, of an impeccable reputation. And she has helped a number of psi researchers analyze their results. One of the groups of results that she analyzed, which for me is perhaps the most convincing of all, has to do with remote viewing. And so there was a group that started doing remote viewing secretively for the US military. And this has now come out into the mainstream literature. And may I take a minute to explain what remote viewing is?
Well, absolutely. This is something I wanted to get into with you. And just before we get into remote viewing, which in itself is a quite extraordinary story that, again, has only recently come out into the mainstream. Before we get into that, Garrett, just tell me, because I understand you're actually doing some of this work with your students at Colorado University.
Right. We do.
which again is fantastic. I've got to ask you, how did you get this past your deans? Like, how did you get this into the program? Because you can't even study parapsychology anymore, can you?
After having come back from my sabbatical, I decided to offer a course on this. And I couched the course in terms that would be acceptable. It's called Edges of Science. And what we are looking at in Edges of Science are maverick science and what's right and what's wrong, and actually doing some experimentation.
Critical thinking, a kind of critical thinking course of some sort.
Exactly. And so at the time, I applied to the College of Arts and Sciences to have this accepted as an honors course in critical thinking.
Ah, right, yeah.
And the committee that was to approve this looked through it, and I had done my homework. I described it in terms of the scientific literature and so on. And the head of the committee asked some questions back and forth by email with me, some intelligent questions. And then finally, he sent me an email and he said, Professor Moddel, I'm embarrassed to ask you this, but could you send me your CV, your resume? We've never had to ask somebody this.
You would imagine they would already have it, being in their employment.
You would imagine, but he wanted to see my publication record. Had I really done science, and did I know how to do it? And so I sent him my CV. I graduated from a big name university. I've been an experimental researcher all my life. And so finally he said, yes, you can have this course. And so it's to the credit, and you can get it approved to give students a credit in critical thinking. So it's to the credit of my university for allowing this. Okay. Among my colleagues and so on, it's mostly been benign neglect. In other words, they don't really bother with what I'm doing as long as I do my mainstream research and have my graduate students and research grants. It's fine if I do this on the side.
Keep your head out of the line of fire. But Dr. Moddel, give us an example then, because if I understand correctly, you started to do some of these experiments with your students. We'll talk about remote viewing in a minute, but is it correct? I seem to remember reading somewhere that after a while, you stopped doing certain experiments in the critical thinking course because the results were always positive.
I would not quite. No, we continued doing these experiments, but we weren't looking for existence proof anymore.
Right.
In the sense that it was obvious, it was clear for anybody who looked at the data that the effects were there.
And how do your students react to this? Young kids growing up with textbook science coming out of college. I mean, how do they react?
It varied. Some students were very open-minded. Some students just said, this couldn't be, there must be something going on, there must be a trick here, there must be something going on that we're not taking account of. It's really, the students really are sort of a microcosm of the general population.
Precisely.
And we see all perspectives there.
And you've done some of this remote viewing with your students in class. Tell us a very basic remote viewing experiment before we go into talking about SRI and how this all started in the 70s. Tell us a little bit about just the most basic remote viewing experiment that you guys did with the box in your class.
So I'll go even a few steps before that and talk about clairvoyance in general. So clairvoyance is the act of seeing something that's not in front of you. You see something that's at a distance, or you see something that hasn't happened yet. That somehow you see something that in your mind's eye.
In your mind's eye, so not with any of the existing senses.
not with any of the existing senses. And in fact, it doesn't even need to be a visual phenomenon. It can also be involve any of the other senses. So it's remote access to any sort of information.
Mm.
And there has been quite a bit of work over the years by many people looking at this until it was codified into this technique called remote viewing. So in a basic remote viewing experiment, you have a tasker, and the tasker is somebody who says, I want you to draw object XYZ on a piece of paper now. And the tasker may say literally XYZ. In other words, what the tasker calls it makes no difference. It simply has to be something that the tasker has some information about, but that's all. And so the object could be the next, something in a hidden envelope, in a closed envelope. It could be something in a box. It could be something in the middle of Russia at the coordinates that the tasker knows, but the tasker has no idea what they are. Or it could be something that nobody knows about, but is going to be shown to us tomorrow. And so at that point, you sit down, and it's a fairly simple technique for doing it. These people who are trained have spent years becoming very good at it, but almost anybody can do it. You simply, to the extent you can, clear your head, and when something unexpected comes into your mind, for me it's usually almost like a line drawing.
A shape.
For me, it's more the line rather than the shape. Different people have it differently. Then just draw it. And if you think you know what the object is, write that down in the column on the piece of paper. And that's called analytical overlay. You don't want to try to think about what the object is. That really just messes it up, because at that point, your mind takes over and starts to try to fill in the lines and describe what it is. Instead, you want the pure sensual information and just draw whatever it looks like. So, for example, one of the first remote viewing sessions that I had after I was taught how to do this by one of the Army-trained remote viewers, Paul Smith. So Paul brought in a box into the room for my class and said, using the techniques that we've described to you, draw what's in the box. And I remember I drew only 3 things on the piece of paper. I still have the piece of paper. I drew what looked like a wishbone. And I remember sort of a shiny, straight object, so I drew that. And then I drew what seemed to me like a spring. And that's all I did. And I put down my pencil. Then he opened the box, and it was a potato masher. So the handle, the thing that holds the masher, and then the masher itself. And I had gotten it pretty much right, but in sort of a cubist way. I'd torn it apart.
Well, it's not very much of an objective kind of phenomena, this, is it?
No.
Well, listen, let's... And you have been using this with your students. What do you reckon? I mean, obviously, it's very hard to evaluate statistically because this is very qualitative, isn't it? But what are your students' hit rates? I mean, what are we talking here?
I would say about 50% of the students get something that is visibly correct, and 50% miss it entirely. In this particular example of the potato masher, we had that sort of distribution. I remember one female student actually drew a potato masher, and then when Paul opened the box, she started yelling and screaming. She was just,
I'm not surprised.
She couldn't believe what happened.
But that is 50% sounds a lot more than what we'd expect, isn't it? In terms of thinking, how many clairvoyant people are there in the world if it even exists? 50% is an extremely generous percentage, isn't it?
I want to correct something you said. You said it's purely qualitative. Actually, you can do this quantitatively.
Well, this gets into SRI's research, doesn't it? Tell us briefly the story of how Russell Targ and Hal Puthoff and Ingo Swann, the famous psychic, got tasked by the Standford Research Institute in the 70s to get started on this research, because it's as much of a mystery to them all these years later as it was when they first discovered it. I mean, I just love the because actually they were publishing their work at the beginning before it became a secret program for very obvious reasons, as we'll find out in a minute, listeners. But the fact that Hal Puthoff, in an interview, this is a public interview, was like, if I had been listening to this interview 3 weeks ago, I would have said that I was mad. Right. I mean, it was such a shock to them. Just tell us a little bit, how did they come to be tasked with this extraordinary sidestep for most of SRI's research?
So I'm not expert on the history of this. I've just read probably what you've read. But basically, these were phenomena that, as you said, Ingo Swann had developed a technique to find, and then through Hal Puthoff and Russell Targ and then later others, the Standford Research Institute investigated them. Because we being the United States, thought that Russia was doing psychic spying, then of course we had to do it too. And so the military developed this secret program that went under several different names. The one it's mostly known by is Stargate. And they then hired the people from SRI and then others to develop this process of remote viewing. And so the process that they developed is what I described to you very briefly, but they had people studying it literally for years so that they were able to clear their head and over the period of an hour or more, look more and more closely at whatever the unknown target was and draw it to quite extreme precision. I mean, architectural quality drawings of places and objects and so on.
And this led to the birth of CRV, didn't it? Controlled remote viewing, which was Ingo Swann's technique. And Ingo Swann pushed the researchers, didn't he? He said, listen, give me something more ambitious. I don't want just envelopes. I don't want researchers the other side of town and saying, where are they? Give me something juicy. Give me coordinates. And this is what led to we won't tell the whole story here, but the extraordinary success. And this led to the interest of the intelligence services. And they started using this, and they continued to use it for 30 years in secret, working with over 5 initial lettered intelligence agencies, getting good results, finding missing persons, finding Russian planes, observing at a distance, psychically, for want of a better word, these things. But there's a really important point here, and you can explain this better than I, that it was blind. Can you explain to the listeners what the protocol was for having blind targets?
Yes. So the blindness is that the remote viewer, the person or people doing the drawing, have absolutely no idea what it is they're being tasked to draw. So if the tasker is being told, okay, I want the remote viewer to draw the next sort of military plane that stealth aircraft that we're going to be developing, that tasker will say absolutely nothing to the remote viewer. They don't even know they're supposed to be drawing aircraft or anything of that nature. And then they simply draw it, and afterwards you look at it. If the viewer has any inkling of what it is they're drawing, it ruins the whole process. Because at that point, analytical overlay takes place, and they start thinking, oh, what might this look like, and what am I supposed to be drawing?
And that would be the frontal cortex coming in. And out of interest, are you aware of any MRI or SMRI studies into the various parts of the brains that's kicking off during this process? Because I imagine the analytical overlay is the frontal cortex coming in over a more intuitive kind of experience. But that's getting off subject a bit.
Yes, there has been a fair bit of work on this. A researcher in Holland, Dick Bierman, has done fMRI work looking at the parts of the brains that are stimulated during these sorts of phenomena. And I don't remember the results that he found. I mean, I remember I have mental images of his.
Yeah. Well, the brain is a very complex thing, and we are going to be speaking to a lot of neuroscientists on the show. And, hopefully we're going to find some neuroscientists who are open to these extraordinary phenomena that are very clearly effective. If the American military are involved, then we know that it works, or they really wouldn't bother, would they? Okay, coming back to the experimenter effect, Garrett, the controller has to be very careful, doesn't he? The controller has to be very careful not to lead the viewer.
Yes, that's true. The tasker cannot give any clues. And in fact, now that remote viewing is a fairly well-known phenomena, there are a number of different groups doing it. And there's a fair bit of criticism by one group of another group saying that, in fact, your tasking isn't as blind as it should be, and that you actually didn't run the experiments as rigorously as you should. You know, it's funny, people on the outside think that there's sort of a cabal of these researchers looking into these strange phenomena, and they're all in cahoots with each other. But it's actually quite the opposite. There's as much debate and self-criticism within this community as there is in any scientific community.
And that brings us beautifully on to the Society for Scientific Exploration. But there was something you wanted to add regarding remote viewing.
Right. I wanted to complete the loop because you had asked me a little bit earlier for another researcher who I thought has done a real breakthrough work. And I mentioned Jessica Utts, the statistician.
Yes.
And so she was commissioned to analyze some of the Stargate remote viewing results. And there, you can make this quantitative in the sense that judges can look at what was drawn and compare the drawn image to either the actual target, which is known later, or a decoy target. And by looking at that, and you can do statistics on how likely it was that the remote viewer drew the correct object as opposed to something random. And so this was done very extensively. I mean, there are thousands and thousands of trials of this.
And one of the most extraordinary things at SRI was the fact that part of their experimentation, quite rightly as physicists, they decided to bring in a random member of the public to show that Ingo Swann was clearly very, very talented in comparison to this random member of the public. And of course, she was also very good at it. Another example of Russell Targ turning up to work and one of the viewers was ill. He took over, and yes, he wasn't as brilliant as Ingo Swann, but actually he did a brilliant job. So it's just very interesting, similar results with your students, that this is not necessarily a talent question. Yes, practice of the CRV protocol clearly helps. Interesting techniques like the ability to, say, move up 100 meters or move back 10 minutes in time, these kind of clear analytical ways of dealing with the material. But this is also a question of ability, and that this could be a relatively universal element. And I think that's absolutely fascinating. Moving to your directorship of, well, your ex-directorship of Society of Scientific Exploration. This was your port of call when you realized that this was part of your calling as a scientist. Tell us a little bit about this society. It seems that you're making great inroads. How are you received in the scientific community, or are you a sort of unknown phenomena?
It's largely unknown. Generally, scientists are highly skeptical of all of these sorts of phenomena that are looked at in the Society for Scientific Exploration, and we're told, oh, this is impossible. It's due to soft-headed scientists and wishful thinking. That usually is the case until people actually get in and examine the data. And there's a lot of data. There's very rigorous work done here. And so we've invited over the years a number of different mainstream scientists to come and get involved in one way or another. And nearly always, these scientists find it to be a revelation and are quite impressed with the quality of science that's being done. There are a number of different organizations looking at, loosely speaking, psi phenomena, but most of them are experiential. The Society for Scientific Exploration, based on its charter, really is looking at these things scientifically and meaning very well-controlled experiments, peer-reviewed publications, and the like. So it is a mixture of real scientists along with the lay public who are interested.
Well, absolutely. And it is, I don't know if you share my enthusiasm, because I'm very new to all of this, Dr. Moddel. I just feel that this is something that the general public really should have access to. I really think it's an important bit of information. This is the end of part one, and we're going to be coming back and we're going to be speaking more about the experimenter effect, but particularly with relation to the observer effect and this extraordinary quantum mechanical phenomena of the observer interfering with a quantum mechanical system. See you on the other side. Okay, welcome back to Chasing Consciousness, everybody. This is part two of our experimenter effect episode, where we're speaking to Professor Garret Moddel at the University of Colorado, who's a professor for electrical and quantum engineering. And what we're coming back into in this conversation, Professor, is a very important question for me personally, and I think for this podcast in general, which is the observer effect in quantum mechanics. We've already spoken to Dr. John Butterworth in our episode about the wave-particle duality, and he is a really, really well-known scientist. And I'm not sure if are you aware of John Butterworth? Working at CERN. So he's working a lot with the particle accelerator at CERN, and he gave us a brilliant breakdown of it. And although he denied any special role of consciousness in the physical world, which is obviously very, very common in the materialist paradigm, unlike early quantum physicists Max Planck and Erwin Schrödinger, who went so far to say that consciousness was fundamental to physical reality, he did concede that John Wheeler's slightly milder understanding of a participatory universe, in which the presence of the observer clearly affects the measurement, he did concede that that was valid. So this is a sort of more of a participatory understanding rather than a consciousness is fundamental understanding. So I thought that was, coming from a practical physicist, not an experimental physicist, not a theoretical physicist, from a mainstream materialist, that struck me as an important concession. And I think it has huge implications for everyday data collection in science and what we're talking about in terms of the experimenter effect and what our intention and our expectation brings to the table, because the observer effect really does show very, very clearly that we cannot observe a quantum mechanical system without changing the results. Is there a connection between this phenomena in quantum mechanics and the experimenter effect, do you think?
So first, let me challenge your description of the observer effect a little bit.
Good. Let's get this right.
So Wheeler was fairly vague in his participatory universe concept. And I think he was vague intentionally.
Mm-hmm.
Is it consciousness? Is it not? Are we really affecting things in a visible way? He was vague. Two other physicists, Wigner and Von Neumann, were more explicit. So
the collapse of the wave function, right? Right.
So to explain that, I'll back up and describe the observer effect a little bit more. So the observer effect is a fundamental quantum mechanical concept that is interpreted via the Copenhagen interpretation. So that is the interpretation of Niels Bohr and others. That a quantum mechanical system is in a superposition of states. It's in an indeterminate state. And it only ends up going to one particular state when it is being observed. And the mainstream quantum mechanical view of observation means when it's registered, when it's taken down on a piece of paper, when it's registered in a camera or in a detector or something like that. Human consciousness is not necessarily part of it.
Mm.
And it really was two physicists, Wigner and Von Neumann, who said explicitly that the observer must be consciousness. And von Neumann's argument was that whatever system is doing the observation, if it's an inanimate system, it still is in an indeterminate state unless another system is looking at the results of that system. And you keep on going, and you can have a system within a system within a system. And where do you stop? And the answer for him was with consciousness. So when consciousness registers it, at that point, you really have made an observation. But let's not fool ourselves. This is a minority view in the physics community.
Absolutely. So coming back to that then, the fact that John Butterworth, kind of gave that concession and said that maybe Wheeler was onto something when he was speaking. I can actually give you the exact quote. You must go back to our wave-particle duality episode, listeners, to get a sense of this, because it was a really fascinating chat. So the quote is, "All matter and all things physical are information theoretic in origin, and this is a participatory universe." So where does that leave us in terms of intention? Do I need to have a mind to observe a physical, as Wigner and von Neumann would put it, a collapse of the wave function, that it collapses into particular physics?
So if you accept this interpretation of quantum mechanics, yes, you need intention. And intention then focuses our consciousness. I use that word loosely because it can be defined so many different ways.
It can.
Focuses our consciousness on the observation, and at that point, we affect the outcome.
Well, and that brings us back to the experimenter effect, doesn't it? Because you're like, can we have a neutral intention? I mean, surely as good scientists, we shouldn't have an expectation. We should be interested in the data.
Yet we're human beings.
We're human beings.
Anytime we focus on anything, we have an intention. If I look at this cup, I look at it with the intention of finding a cup. So I've defined it as a cup. It's not a random act. It's an act of intention to look at it. You can't help that.
And where do you lie on this very, very broad spectrum?
So I am skeptical.
Even to this day. Interesting.
Even to this day. So one thing that is incontrovertible, if you look at the data, is that our intention does affect random phenomena. So we do affect the output of a random number generator, for example, which puts out zeros and ones based on random quantum mechanical phenomena. So there's no question that our intention affects these random phenomena. If you deny that, then you just haven't read the literature. On the other hand, I don't know that I can say that about all quantum phenomena. It could very well be that for many indeterminate states, they do fall into a final state, as it's often described as collapse of the wave function, based upon registration by an inanimate object. So I'm not going to say it's always.
Well, that brings us rather beautifully on to one of Schmitt's experiments. So Helmut Schmitt, listeners, again, please go back to part 1 and listen up to the introduction to the random number generator, the RNG, beautifully introduced to the field by Helmut Schmitt. Could you explain to us one of his most extraordinary results ever, which I think he anticipated?
So we had talked about Helmut Schmidt's experiment in which a random number generator created a click in the left or right channel of headphones that a subject was wearing. And the subject could, using their intention, have more of these clicks come to one side or another. So then what Schmitt did is he put the subject and the experimenter aside and simply recorded on a stereo tape recorder, which was being used at those times. It was pre-digital era.
Probably more reliable in terms of this kind of backup.
It is. So he recorded the output of this electronic random number generator that produces left and right bits. He recorded it, made a tape recording. Then he took that recording and made a duplicate of it and put that duplicate in a vault. After that, he took the first recording and he played it to a subject who had headphones on and was listening to the left and right channel of the stereo recording. And the subject, again, used intention to produce more clicks on one side or another according to a protocol. And the subject was able to do it. The experiment worked just as well as the real-time experiment, even though the data had been pre-recorded.
Right.
Then Helmut went even a step farther, and he took the tape out of the vault that had been stored, and he played it back. And that tape now had the same increase in left or increase in right number of clicks that the tape had that the subject used in listening to the pre-recorded clicks.
Cue audience, cue listeners, your jaw hitting the floor. Now, Dr. Moddel, please confirm, this sounds like retrocausation. Is that what it is?
So it's a very subtle, the answer is very subtle. And let me explain it in terms of Schrödinger's cat.
Which brings us back to the collapse of the wave function.
Right. So Schrödinger was dealing with this concept of the observer effect and that the wave function doesn't collapse until an observation takes place. And he was skeptical of this thing, and he actually came up with what has become known as Schrödinger's cat to show how foolish this all is. But so what he said is, let's take a cat and put it into a chamber, and in this chamber there's a vial of cyanide, and that cyanide is either going to be spilled out or not based upon a quantum mechanical random phenomenon, a decay of a particle. We're putting that cat and the vial and everything into that chamber for a few days. Then he said, before we've opened up the chamber and looked at it, the cat is neither dead or alive. It's in this indeterminate state. And in fact, it's now even called a cat state in physics these days. Then when you open up the chamber, you either will find a living cat, or you'll find a cat that may be have been dead for a few days and stinks. But the question is, when you're making that observation and causing it to fall into one of these two states, either alive or not, are you retrocausally going back and causing that cat to have died 2 days ago? Or is everything just occurring the moment you open the vial?
Isn't there a difference here because Helmut Schmitt recorded the first listening? So the first set of clicks he recorded. So in that sense, he opened the box and then he closed it again.
No, because the recording was in a cat state.
Because he hadn't listened to it. He hadn't.
Exactly. So the recording was in an indeterminate state. So even though it was a physical recording on magnetic tape, only when the listener came and listened to it did it collapse into a well-defined state.
So that was presumably quite an important part of the experiment, that he wasn't allowed to listen to this recording.
Absolutely. And in fact, Schmitt did a later series of experiments in which he had two listeners, and he found two sequential listeners. And he found that the first listener essentially cemented the state of the system, so that by the time the second listener came along, the second listener could no longer influence it.
Well, the reason that I mention this is because we're going to do a show on this. There was an extraordinary version of the wave particle, the double slit experiment, which I'm sure you've heard about, where they were using various distances of sensors from the slits and using this phenomena, the cat state phenomena, to basically show that there was a delay before a wave that was either a wave or a particle was being received into certain sensors, and that the original sensor that was closer to the split beam was receiving information before, and yet it was changed by the later readings in the received sensors. Now, I've explained that very, very badly. Please tell me you've heard of this experiment and you can help us here.
I've heard of a variation of that. So this is actually Wheeler was one of the people who originally came up with this whole delayed choice sort of experiment. And it is very much like the experiment that we discussed with the random number generator. It's where something is in an indeterminate state until it is measured. In the case of a double slit experiment, makes use of waves going through two slits, and those waves superimpose either peak upon valley or peak upon peak or valley upon valley, depending upon the distance between the screen and the slits. And so what you end up is having a diffraction pattern, meaning light, dark, because of the interference of these waves after they've come through the two slits.
Right.
However, in these delayed choice experiments, you turn down the intensity, so you just have one photon, one piece of light coming through the slit at a time, and you say, well, it can't interfere with anything because it's there by itself. In fact, it gives the same sort of peak and valley structure that you have that was had if you had a lot of these waves, unless you measure it. And if you happen to measure it first before it goes, or you measure which slit it's gone through, at that point you've destroyed this indeterminacy, and you no longer get the peak valley situation. And so the delayed choice simply means that you can wait until the light has been launched before you make the choice as to whether it's going to act like a wave, meaning forming this diffraction pattern, or act like a particle, meaning you detect it at a certain place.
So the potential for some form of retrocausation, or in consciousness terms we might talk about precognition, is basically explained by the quantum mechanical paradox of the wave-particle duality, and the fact that until there is an observer, actually, in a way, there is no definite state, and therefore there is no sense of something being retro-caused, because it was never actually either one thing or the other. It was a pure potential rather than a definite one or a zero in that sense.
So we've got to be careful here. It's quantum mechanical-like. So in other words, we can use quantum mechanics as an analogy for these phenomena that we observe in psi experiments. But to say that they actually are quantum mechanical would require then some rigorous experiments in which we test whether they're quantum mechanical or not. And that hasn't been done. So I'm actually a bit of a skeptic in the field in saying that, yes, we affect random phenomena with intention, but to say we're collapsing the wave function, I don't know. We can affect anything that's random with our intention.
It's too early to say, isn't it? It is too early to say.
Yes.
Okay, but this brings us beautifully on to another example of the experimenter effect, or potentially, I should say, this is the field is out. One of your colleagues at the PEAR labs in Princeton launched the most extraordinary project, really quite some time ago. Can you tell us a little bit about the Global Consciousness Project, and how these random number generators, again, thank you, Helmut Schmitt, were used in these early experiments, and how this became a global network?
This started off with Roger Nelson and Dean Radin, who were at the PEAR lab. And,
at Princeton, yeah.
At Princeton. And what they ended up doing was having a series of random number generators around the world. These random number generators were putting out random bit streams of zeros and ones, which were then being sent back to Princeton, and the Princeton lab tabulated the results. These researchers wanted to see whether, in fact, the randomness of these different random number generators was somehow broken by any sort of world phenomenon occurring in which people focused their intention in some way or focused their attention in some way, and whether there was going to be any sort of correlation among these different random number generator bit streams that were coming to Princeton.
So these people had no awareness of these random number generators being, shall we say, in their vicinity?
No. So, for example, during the Academy Awards ceremonies, a large fraction of the world is focused on their television screens, looking at the award ceremony, and in particular, who's won the Best Actress Award or whatever. And so it's simply a matter of many, many minds focusing on something at the same time. And Roger Nelson, who essentially became who ended up running this Global Consciousness Project, found that when intention was focused, when global attention was focused, that the randomness of these different random number generators changed, and they became less random. And there were many different sorts of events. The one that had the biggest effect was the 9/11 terrorist bombing. And during that whole period, the random number generators deviated greatly from what they would have put out if they were purely random. And you could see that, in fact, there was some sort of, he would say, global consciousness producing a correlation among these different random number generators.
So this is still running. What are the implications of this? I mean, in terms, it sounds like there's some sort of field of attention between minds or out in the public space. I mean, if nobody's focusing on the random number generator with their intention, surely the random number generator is somehow tuning into some sort of communal unconscious or some sort of field. Is that where the theory is going? Is that Roger's approach?
Okay, Freddie, I don't know how much you want to go into this, but I'll answer your question and stop me if I'm getting into the weeds too much.
No, it's really important. We're going to be talking a lot about the psychology of a potential communal unconscious on this podcast.
So the Roger's view is that, yes, in fact, this is showing that there is a global consciousness, and that somehow this global consciousness is affecting these eggs, as he calls them, which are random number generators placed around the world. And the experiment is being run to this day. They make all their data public. Anybody can go in and analyze it. There's nothing secret there. And you can see statistically how these effects occur. So yes, that is the conventional view among this group of nonconformists looking at the Global Consciousness Project.
What do they call it? What do they call this field, out of interest?
So it is field consciousness.
Interesting.
Field consciousness, and you can run it as we've described, or you can actually take a random number generator and go to a sporting event and have the random number generator produce bits. And during periods where people are really excited, this a goal was made at this time and it was particularly exciting. At that time, there'll be a major deviation from randomness in the electronic random number generator. So there are many sorts of ways to measure this field consciousness.
And you're convinced by the statistical deviation from randomness?
Yes, no. So here's where you'll need to allow me to go on. I'm skeptical of this whole thing. It is a psi phenomenon. There's no question about that. The data is robust, but the interpretation is in question. And one of the first people to question it was the same person who developed the electronic random number generator, Helmut Schmitt. He wrote a letter to the Society for Scientific Exploration, to the Journal of Scientific Exploration. And this was, a number of years ago. I actually communicated with him about this before he died. And he said, there's something really wrong here, that all of these different electronic random number generators around the world have a delay associated with them, because there's a delay between when those bits are sent and when they arrive in Princeton. And because of that delay, if you see different electronic random number generators giving you the same result and they're all around the world, that doesn't make any sense if they were putting out bits which at the time they put them out were coordinated, because the time they'd arrived to Princeton, they'd now be in disarray because of the different times of transit. And he said this could not be a measurement of field consciousness. Instead, he said, it must be the intention of the experimenter, back to the experimenter effect. And it's actually Roger Nelson's intention that causes these things to be coordinated. Since then, other people have looked at it. One of Roger Nelson's collaborators, a fellow called Peter Bancel, looked at this in detail. And he wrote several papers in which he said, this is not a global consciousness effect. Because of several other phenomena, and I won't go into the details here, but there's a randomization process that's used by these electronic random number generators. And he said this it's sort of like an egg beater. And this randomization process would have destroyed any of the sort of initial randomness from global consciousness. And again, it must be due to Roger Nelson. Then came along this guy called Garret Moddel. And so I gave a talk on this a couple of years ago. And that is something I call cybotics. And cybotics is where you use your intention to affect how a machine works. And one of the cybotic machines that you and I have already talked about is the double random number generator experiment that we spoke about, in which a random number generator was supposed to anticipate its own demise. And then later I found out that in fact it was our mind, the mind of the experimenters, that had essentially programmed it to do that. And so that is cybotics, where we program a random system to do something. And there are a number of other examples that we could get into if you wanted. But
is there a way around it? Surely you could fix the experiment with this knowledge.
Not really, because the experimenter intention, the experimenter expectation leaks in. It always leaks in. So, for example, the global consciousness experiment, I believe, is a very grand cybotic instrument. Roger Nelson uses his intention to make all these random number generators around the world sense consciousness. And so, yes, it really is a global consciousness experiment. It really is working the way that Roger wants it to. But the reason it's working that way is because he wants it to.
But couldn't another researcher set up exactly the same experiment and compare the results?
Yes. Yes, you can have somebody else run another experiment in parallel, or a different sort of experiment with a different intention, and see if they get the same result or not.
It is, once again, despite, very possibly, certainly in your opinion, being an experimenter effect rather than a genuine global consciousness field, both are side effects. So,
and I'm saying, in fact, it is a genuine global consciousness field effect, because Roger intends it to be that way. So in my class, I ran a class in which students did all sorts of experiments on psi phenomena. And one time we invited a very well-known skeptic, Victor Stenger, who's actually written books on skepticism, to come and monitor our experiments. And we had a series of experiments in which he sat in the room monitoring what was going on, and then we ran the exact same experiments without him being in the room. When he was not in the room, they worked well. When he was in the room, we got what's called a psi missing effect. We got, not only did we not see the effect we wanted, we saw a statistically significant opposite effect. And so observers matter. The experimenter matters. The intention of the person matters. Because he absolutely was dead set against believing this could work, he made it not work. But he actually did it too strongly. He made it go in the other direction.
But where does that leave us in terms of the fact that the experimenter effect and the intention of the observer is so powerful, which is in itself a psi effect, but where does that leave us in terms of scientific data collection? Because basically, doesn't this totally undermine all scientific data collection?
I don't think so. I think that there are some experiments that are susceptible to this and some that are not. So, for example, if you take a hammer and you hit a bottle and it shatters, no amount of intention on your part or any observer's part is going to make that bottle not shatter when you hit it. Really, there have got to be random, there's got to be a fundamental randomness in the experiment. And I believe it's a randomness at the quantum level, a randomness due to thermal noise. It could be due to 0-point energy fluctuations, but any sort of fundamental fluctuations. So if you've got an experiment in which you've got these fluctuations that give rise to the outcome in the effect, that's where intention may be affecting what you get.
Absolutely. So that brings us to the last part, and quite a big part of your conventional research into harnessing the quantum vacuum for a generation of energy, a sort of holy grail of all of the energy problems, the green energy problems of our world. Sometimes called the free energy movement, often associated with a lot of woo-woo and a lot of consciousness, new age kind of principles, and extremely skeptically seen in the mainstream, physicalist world of the scientific community. Tell us a little bit about your research into the quantum vacuum and into sometimes known as 0-point energy. Tell us where you've got to. How long have you been working on this?
I've been working on it for 15 years now.
Wow.
And actually, I was introduced to the subject through the Society for Scientific Exploration. A physicist working in California, Bernie Haisch, who's a theorist, and he had come up with a way to potentially harness energy from the quantum vacuum, and he needed an experimentalist to work with him to try to actually create an experiment and make it work. And so together we wrote a patent application on this, and surprisingly it sailed through the patent office, and so we have a genuine patent for harvesting 0-point energy. And then we went about trying to verify it. And so I wrote proposals. I wrote one proposal to DARPA, which is the defense agency in the United States that funds very experimental and avant-garde research. And I was given the grant. And so we carried out the research, and then we also ended up having some private money as well to fund the research at the University of Colorado. And we came out with actually seeing energy that was being radiated from this experimental apparatus. And my student at the time, who was very careful, she worked through all possible other thermodynamic origins for this energy we were seeing, and none of them worked. But I remain skeptical as to whether we actually were seeing energy from the quantum vacuum or not.
Can you back up a little bit and tell us what exactly it is, or is that?
Yes. So in quantum mechanics, one fundamental principle is the uncertainty principle. And it says that when you cannot measure two linked properties of a material of an object at the same time. For example, if you've got a particle, you can either measure its momentum or velocity, how fast it's moving, to absolute precision, or you can measure where it is to absolute precision. But you can't measure both of those at the same time. The more you know about one, the less you know about the other. And it's a very rigorous formula for telling you how much you can know about this. And if a particle stood still, then you would know where it was and you'd know how fast it was moving. So therefore, no particles can stand still. And so this fundamental jittering of everything is zero-point energy. It's zero-point energy fluctuations. And not only do particles undergo zero-point energy fluctuations, but free space itself does as well. So a vacuum, which supposedly has nothing in it, actually has waves that come into and out of existence. And this is the quantum mechanical vacuum. And it's these waves include electromagnetic radiation. And this electromagnetic radiation should have properties that are measurable. One of these was predicted in 1948 by a guy called Casimir, who worked with Niels Bohr to understand what it was he mathematically found. And he said that if you have a very narrow cavity with reflecting walls, that in that cavity, only certain wavelengths of light can exist because of the reflection condition of the walls. Whereas outside the cavity, all wavelengths of light can exist. And if that light that you're talking about is these zero-point energy fluctuations, that means that you're going to have more of them outside than inside. And there will be a radiation pressure pushing on the two walls of the cavity, pushing more together than the inside radiation is pushing out, because there's more outside than inside. And so he predicted that this Casimir cavity ought to collapse. It was many decades until people were able to measure this, because these walls have to be very close, less than a millionth of a meter apart, in order to get a significant force. But people have measured it over and over, and in fact, it's correct. And so this is viewed as a manifestation of the zero-point field.
So in some sense, inside that collapsed cavity is that light photon, that tiny particle of light is still in there, ready to be harnessed.
You describe it interestingly. If you could pull it out, yes, it would be, but presumably it's reabsorbed by the vacuum.
Right. And presumably therein is the experimental difficulty, is trying to extract it. Theoretically, makes perfect sense, but it's the extraction that's the issue. But this is, I mean, it's not surprising that DARPA were interested in this. I mean, lots of really important scientists, Dr. Hal Puthoff, who we mentioned regarding the SRI research, has been interested in this for many, many years. Dr. Edgar Mitchell of the ions, ex-NASA astronaut, was interested in this for many, many years. Lots of people do believe it. Why is there so much skepticism in the field? And, well, let's start with that. Why is it so laughed at in the mainstream?
For a few reasons. One of them is that the vast majority of what you correctly call the free energy movement, the vast majority of the work carried out by these people who are in this field is really wishful thinking. It's poor experimentation, results that are not borne out by attempts to replicate them. And so there's reason for derision. There's reason to say, you know, it just probably ain't there. The experiments weren't done right. Another reason for the skepticism is that this notion that I described from the uncertainty principle of having energy, of having particles move all the time, that is a fixture of quantum mechanics. But most physicists view it simply as a fixture. It's not something that's extractable. You can't really get that energy out. It's just there. And in order to get it out, there have been some interesting papers on negative energy states in systems and so on, and that these negative energy states occur for such a small time that it would be absolutely impossible to go in and grab them. And so it's
But
viewed.
15 years in the field is a long time. You must have some pretty good reason to believe you can get it out.
I am believing that yes, maybe there are ways to do it. That it's really more of an engineering problem than a fundamental problem. And I think there may be ways. Just a month ago, this same DARPA organization that I said funded us more than a decade ago, they put out a request for proposals specifically on harnessing energy from the zero-point vacuum. So once again, DARPA is interested in this, and I think it's going to stir the pot. I think that people are going to be looking more closely at ways to potentially do this.
It is really a game changer, isn't it? I mean, is there a part of you, a sort of deeper part of you, that feels that this is really something that could be used to change our current energy paradigm, our potentially self-destructive streak?
It would be so wonderful. I mean, it would imagine all of the self-destructive energy sources that we would be able to avoid. My experimentation is all public. So the results of our initial experiment are all published. I actually published a paper that's freely accessible about 6 months ago that summarizes all of this. So it is something that people can look at.
Well, thank you so much for this brief introduction to it. And I think trying to go into too much detail would probably be counterintuitive, because it is very, very complex physics. So just to wrap it up, we've come from talking about the experimenter effect being a genuine issue, particularly in certain types of experiments. We've realized that this is a psi effect, something which is very new to me and probably very new to most of our listeners. What are the implications of this? You sound like a pretty sort of on the fence kind of guy. You're not willing to go even far enough to say Wigner and Von Neumann, with their collapsing of the wave function conception of the Copenhagen interpretation, were correct. I mean, what can you say, like in terms of your worldview as a scientist, as a person? What are the implications of psi phenomena, in as much as you've noted that they are real?
So, as I mentioned to you earlier, I've come into this kicking and screaming that I really don't want to let go of my mechanistic view. And so we tried to set up experiments in which we avoided having to have any sort of consciousness intervention. I've really tried to keep a purely physicalist view, but I'm afraid I've lost. Really, there is a fundamental part, if not dominant part, of this world that is affected by consciousness, whatever that is. We can't avoid it. And I'm not saying this as an opinion. I'm not saying this as a philosophy. I'm saying this from looking at the data. Consciousness does affect our experiments. So far, we know that it affects random phenomena under a certain set of conditions, but who knows, maybe it's affecting much more than I'm willing to admit at this point.
Do you feel tied? Do you feel tied to any one of these particular sort of positions that are now emerging in consciousness studies?
So, we talked about electronic random number generators, and we talked about the Princeton Engineering Research Lab and Bob Jahn, the Dean of Engineering there. And perhaps we can connect those to this question you've asked. When Bob Jahn had the Dalai Lama visit his laboratory. There were a number of different pieces of apparatus in which intention controlled some sort of physical random phenomenon that Bob showed him. On the way out, the Dalai Lama asked Bob, "Do you have any questions for me?" And Bob said, "Yes, this electronic random number generator, is it conscious?" The Dalai Lama thought for a moment, and then he said, "If you want it to be conscious, it's conscious."
It's the experimenter effect. I mean, goodness me, maybe we should create a new position, which is the sort of the experimenter of position.
I think, and this is really just a thought, but I think that not everything goes. There are some phenomena that you can affect, some phenomena you can't affect. Again, back to the breaking the glass with a hammer. I'm not going to affect that with my mind, but more subtle things we are going to affect. As to how you can affect some things and which you can and which you cannot, we've got to sort that out.
So what's next for Cybiotics? What's next for your mainstream research?
Really, the issue here is to try to find out how to do an experiment with enough repeatability. What are the parameters that cause an experimenter effect? Is it purely psychological, or is there something fundamental going on in these pieces of apparatus that are being controlled? What is it that we can control to do these things? Yes, we know we get these effects. We get them over and over. How can we control this more? Or perhaps if we can't control it, what part of the nature of reality are we dealing with, and what are its rules? These are the sorts of questions we're trying to answer.
Well, with that in mind, I would like to thank you very, very much, Professor. It has been a fascinating and really, for me, hugely mind-opening experience to talk with such an experienced scientist about stuff that, you know, again, 6 months ago, if you told me this stuff was real, I would have laughed. I would have thought, yeah, probably in, you know, some serious pseudoscientific way. But it is very, very clear to me, and I hope to all of you listeners, speaking with somebody of this rigorous nature, that we really, really need to take this stuff seriously. And as you say, Dr. Moddel, I think it is really important that we do try and understand better where the delineation lies between where side effects are really important and to be considered by the general scientific community, and where we should really just not go there, because perhaps we are shooting ourselves in the foot by trying to overstate the argument. Thank you.
Thank you.